question yesterday when we're resolving into components, okay? So just remember that. Okay, so we're going to look at resolving into vertical and horizontal components. Okay, so this is just to remind you so you can get the trigonometry right, okay, when we do it. Now, I've got a force like that at an angle theta to the horizontal. Okay, now we want to split that force up into a vertical component and a horizontal component. Okay, so by trigonometry we can see which is which. So if the hypotenuse is F, so the vertical component is going to be F sine of theta, and the horizontal component is going to be F times the cosine of theta. Okay, and this is true as long as you know the angle to the horizontal. It doesn't matter which way the force goes. So if I've got a force going like that, angle theta to the horizontal, the vertical component is F sine theta and the horizontal is F cosine theta. Okay, so when we're resolving, if we know the angle to the horizontal, the vertical component is always F sine theta and F cosine theta, and if we know the angle to the vertical, they switch round. So instead of that, if I've got a force and I know the angle to the vertical, in this case the vertical is going to be F cos theta and the horizontal is going to be F sine theta. So it depends whether we know the angle to the vertical or to the horizontal, which way round it goes, but once you know that, it's always the same. Okay, so that's when we resolve into components. Okay, when we've got that, you can either use sine rule and cosine rule, which we're going to get to later, or you can do vertical and horizontal. Yeah? Even if it's not right angled, you can still do it. You can resolve every force vertically and horizontally. Okay, so let's have a look at an example of one where we can do it vertically and horizontally. So remember what equilibrium is. All the forces, the net force is zero, so it's horizontal force is balanced and the vertical force is balanced. So let's have a look at an example where we've got a light fixed to two walls. Okay. So here's our diagram. It's not a force diagram yet. It's a space diagram. So we've got a 10 kilogram light hanging from a wall, the roof, and fixed to the wall. So let's have a look at that. So what would the force diagram look like? Just the free body diagram. So that's a space diagram. What would the free body diagram look like? Okay, so we'd have the weight down. Yep, so we'd have, so that would be the 10g, because weight is mass times g. And then what have we got? We'll have force that way and one acting like that. So we'll call this one TS and this one TC. Okay, so there's the force diagram, or the free body diagram for that. Now, what can we do there? If it's in equilibrium, what's going to happen? Yeah, so if it's in equilibrium, so it's in equilibrium. So the sum of the vertical forces, forces equals 0, and the sum of the horizontal forces equals 0. Okay? So I hear you're happy drawing it with the table version for the different forces? Yeah? Okay, so let's have a look at the table version. So we've got, what are the forces? We've got the 10G force, we've got TS and TC, so a vertical component, and the horizontal component, and then at the bottom we're going to have the resultant. It's in equilibrium, so what's the resultant got to be? 0 and 0, yeah, 0 for the vertical and 0 for the horizontal. So what can we fill in for numbers? The 10G force is acting vertically downwards. So we have to define positive and negative. So let's just define, if we just say that that's positive and that's positive. Yeah? Okay, so the 10G has a vertical component of, so we can say, so that equals 10 times 9.81, which is 98.1 newtons. So, but it's down, so it's negative. Yeah? What other ones can we fill in? Sorry? Yeah. So TS has, okay, so yeah, so the 10G has a 0 horizontal component. So what other ones can we fill in that are 0? Yep, TS vertically is 0. No, so that's it. So they're the ones we know. Yeah. So now, what's the vertical component of TC got to be for it to add up to 0? Yeah, so we're going to have plus 98.1 newtons. Yeah? And there's nothing else we can fill in at the moment. Okay, what can we work out? So let's see if we can work them out. Let's have a look at, let's use TC. Okay, so here's TC like that. We know that the vertical component there has to be 98.1. Yep, so we know that that's 30 degrees there. So which one's which? Which one's 30? That one there, 60. Yeah. So we know that. So now, by trigonometry, what does TC? TC is the hypotenuse. The 98.1 is the opposite. So we can say sine of 60 degrees equals 98.1 over TC. Is that right? So sine of 60 degrees is 98.1 over TC. So we can rearrange that to find TC. So what does TC equal? (98.1) divided by sine of 60 degrees. Yeah. So we can do on our calculator, we can go 98.1 divided by sine of 60, and you get 113.2. Yeah, to 4 significant figures. So we get 113.2. Okay, so we know what TC is now. So we've worked out TC. Okay, so we've worked that one out. Okay, so we know TC now. So what can we do? We know TC. So what's the horizontal component of TC going to be? Horizontal component of TC is going to equal TC cos 60, yeah? So equals TC times the cosine of 60. So that equals 113.2 times cos 60. And what do you get on the calculator for that? 49.05. You sure? Because cos 60 is a half. So 113.2 times cosine of 60, 56.6. 56.6. So we know our horizontal component now is 56.6, but it's going to the left. So it's minus 56.6 newtons. So what does the horizontal component of... Sorry? You could? Did you 98.1 squared minus... No, we've got the hypotenuse. We're working out one of the shorter sides. So it would be 98.1 squared... Sorry, 113.2 squared minus 98.1 squared, and then square root that. Okay, so we know we've got 56.6 newtons to the left. So what does the horizontal component of TS have to be? 56.6. And that's the only one it's got. So we can work that one out. So we can do that with the table. Sometimes it's easier just to write equations out, okay, rather than doing it by the table. Shall we go through it by the equation way to make, so you can get a different way of doing it? Okay, right, so that's if you use the table way, okay? Now, the other way that I would do it is just by equating forces. So if we answer it by equating vertical and horizontal forces. So if we equating vertical forces, right, so up must equal down, yeah? Because it's in equilibrium. So what are the forces going up? The only force we've got going up is the vertical component of TC. And if we've got that 30-degree angle, the vertical component is the cosine of that. Yeah, so I can write TC cosine 60 degrees equals, the force down is just the weight, our 98.1. So rearrange that, TC equals 98.1 divided by cos 60 degrees, and if you have a look, that's exactly what we had here. So this is quicker, but you get to the same answer. So TC equals 113.2 newtons. So now we can equate the horizontal forces. So if we so we can say that left equals right. Okay, so what have we got acting left? We've got the horizontal component of TC. So the left would be TC, and if the vertical was cos 60, the horizontal must be sine 60. So TC sine 60 degrees equals, and what's the force acting right? TS. So we can say TC, so we can 113.2 sine 60 degrees equals TS. And then on your calculator, okay. No. Where have I gone wrong? Can you see the mistake? Because that's not going to give the right answer. If I have 113.2 times sine of 60 degrees, we get 98. So where have I gone wrong? If I've just done my trigonometry wrong. If I've got, what is the horizontal component of that? Horizontal component of that would be sine 30, not sine 60. Okay? So that should be cos 60 or sine 30. So that was me going the wrong way around. So that's sine 30 degrees in there, which gives us our 56.6, yeah. Okay, so just be careful whether you use the right one, the sine or the cosine. That's me being a bit dumb on a Wednesday afternoon. So we can do it two ways. We can either use the table version and put in all your horizontal and vertical components, or you can just resolve vertically and resolve horizontally to work out the answer. Okay? So let's look at an example when it's not right angles. What do we do when it's not right angles? Because it makes it harder. So here's our force diagram, our free body diagram. Let's have a look at it. Okay, we've got 400 kg mass. We've got tension 1 and angle theta there, and we've got another force over here, 2 kilonewtons. And we're told that that angle there is 115 degrees. And what we want to do is we want to find T1 and the angle theta there. Okay. So, if you remember, we can draw forces one after another as a diagram, nose to tail, and we can get a polygon of forces. So here we've got 3 forces. Okay, so let's start with the easy one, which is the weight going down. So if we draw a triangle of forces, we've got our mass acting down, so that's 400 times 9.81, which is equal to 3924 newtons. Then we've got our 2 kilonewton force acting this way. Which is 2,000 newtons. And then, if this is in equilibrium, the polygon's closed. Yeah? So we're going to say it's in equilibrium. So that must be T1. Right. We just put the system is in equilibrium because okay, so we've got a triangle there that's not a right angled triangle. Do we know any angles in that? Yep, because if that's 115, this one in here must be 65 degrees. So there's 65 degrees there. And this one up here is theta, the one we're trying to find. Okay? So there's our triangle of forces. We need to be able to solve that. So who remembers their non-right angled triangle trigonometry? Sorry? Yeah, so before we can actually answer that, what do we have to remember? We have to remember our sine rule and cosine rule. So let's put this over here so we can remember it. We've got trigonometry in non-right angled triangles. Okay, so if we have a right angled triangle, non-right angled triangle. Now, we're going to label the angles A, B, and C, and then when we use sine rule and cosine rule, the side has the same letter as the angle opposite it. So if that's angle A, the side opposite is called side A, and we use a lowercase instead of the capital. So here's angle B, so opposite side is side B, and there's angle C, and opposite would be side C. Okay? So in any triangle A, B, C, we have two rules. We have the sine rule and the cosine rule. So the sine rule, and you get given these on the formula sheet so you don't have to remember them, is A divided by sine A equals B divided by sine B equals C divided by sine C. And whenever you're using the rule, you only ever use two of the three fractions. You don't use all three at once. Okay? Now that's the normal way of the sine rule, which we use to find sides. So that's to find sides. And if you want to find angles, you just flip it upside down. So we can say sine A over A equals sine B over B equals sine C over C, and we use that to find angles. And that's the sine rule, and then we have a cosine rule, which is A squared equals B squared plus C squared minus 2BC cos A. Okay, and that way we use it to find sides. So that's to find sides. And if we want to find angles, we rearrange it. So if I rearrange it, I can say the cosine of A equals B squared plus C squared minus A squared divided by 2BC. Okay, so that's just rearranging that equation. Take the minus 2BC cos A across to the left, take the A squared across to the right, and then divide by the 2BC. Okay, so that's the cosine rule to find angles. Yeah. So now, a quick tip on which one you have to use. We've got a non-right angled triangle here, and you have to decide what to use to find T1 and what to find theta. Now, it's really easy to decide if you're going to use the cosine rule, and if it's not the cosine rule, it must be the sine rule. Okay? So the way I remember it is, if you want to use the cosine rule to find a side, we need two sides and the angle between them. Okay, if you don't know that, you've got to use the sine rule. But if you know two sides and the angle between them, we can use the cosine rule to find a side. If we want to use the cosine rule to find an angle, we need to know all three sides. Okay? So if you know all three sides and you want to find an angle, you can use the cosine rule. If you're trying to find an angle and you don't know all three sides, you've got to use the sine rule. So that's the way we're going to try and remember how to use it. So this problem here, first of all, we're going to look at finding T1. So if we have a look at T1, what do I know? I know this side and the angle between them. So it's the cosine rule, okay, to find a side. So we're going to use the cosine rule. So we can say using the cosine rule, okay, so when you're using the cosine rule to find a side, this is the side you want and the cosine of the angle opposite the side you want, and the B and the C are the other two sides. So we can say, we're trying to find T1, so we can say T1 squared equals, and then it's B squared plus C squared, so it's each of the other sides squared, so it doesn't matter which order you put it in. I can put 2000 squared plus 3924 squared minus 2 times each of these numbers times the cosine of the angle between them, so times cosine 65 degrees. And you just do that on the calculator and then square root it. So let's see what we get. Make sure your calculator's in degrees, by the way, for these. So 2000 squared plus 3924 squared minus 2 times 2000 times 3924 times cosine of 65. And on my calculator, I get 12764,359.76. So T1 is going to equal the square root of that. So on your calculator, you just go square root of answer equals. So basically, we get 3572 newtons, which we can say is 3.572 kilonewtons. Okay, so we can use the cosine rule in our triangle forces to get that. Now we want to find this angle theta. Now, I've worked out the third side, so I could use the cosine rule to find the angle, but that's a rounded answer, so it'd be better to use the ones we've already got. So we can use the sine rule now. So if we're going to use the sine rule to find an angle, we're going to use it that way up. So always start with what you're trying to find. So we're trying to find angle theta. So I start with sine of theta divided by the side opposite. So the side opposite is 2000. Equals, and then the angle I know is 65 So it's sine 65 degrees divided by the side opposite, which is the one we've just worked out. So 3572. And now we can just rearrange that. Bring the 2000 to the top. So sine of theta equals 2000 sine 65 degrees over 3572. And how do you go from a sine, a cosine, or a tangent of something back to the angle? Inverse, yeah, great. So theta is going to be the inverse sine of all of that. And we can do that on our calculator. So we bring up shift sine to bring up inverse sine in the open brackets. 2000 sine 65 divided by 3572. And we get 30.5 degrees. Okay. So we can use, when we get a triangle forces with non-right angled triangle, we need to use either the sine rule or the cosine rule. Okay, now, who's comfortable using the sine rule and the cosine rule? Or shall we have some practice? Yep. Yep. Yep, and then you open a bracket. Yep. 2065. Have you closed the bracket after the 65?
Oh, no.
You need to close the bracket on that particular version of the calculator. You need to close the bracket on the 65.
Oh, okay, cool.
Yeah, and then it should work. The old calculators didn't put things in brackets, so you didn't need them, but those ones open a bracket automatically, so you have to close it. So you'd have to go sine 65 closed brackets divided by 3572 closed brackets again. Yeah. And you should get 30.5.
Yeah.
Good. Awesome. Right. Right, so let's just have a quick practice using the sine rule and the cosine rule before we try some other false questions, because you have to be quite good. And a lot of these problems, they're actually easier to solve using the sine rule or the cosine rule than it is by resolving vertically and horizontally. Because if you haven't got any right angles in there, when you resolve vertically and horizontally, you end up with simultaneous equations you have to solve.
What? You could use the simultaneous equation.
Yeah.
Well, then can we do it for us?
We'll haven't, when we go through an example, we'll do it both ways. Okay? Right, so let's have a look at this. If I draw a diagram for you. Now, these are not to scale. Right. 60 degrees, 17 centimetres, 19 centimetres. And I want you to find this angle here. Okay? So we're going to try and find that angle. So first of all, we've got to decide, are we going to use the sine rule or the cosine rule? And just use those tips I gave you earlier. Okay. We're trying to find an angle. Do I know all three sides? No. So I can't use cosine rule, so I must be using sine rule. So we're going to use the sine rule. Okay, so I'm going to use the sine rule. And we always start with what you're trying to find. So I'm trying to find an angle, and when we're trying to find an angle with the sine rule, we use it with the angle on the top. So I'm going to start with sine of theta divided by, and we always go with angles and sides opposite each other. So what side is opposite theta? 19. So we can write sine theta over 19 equals, we need another angle, we know the 60 degrees. So I can write sine 60 degrees divided by, what's the side opposite 60 degrees? 17. So now we've actually used the sine rule. Now it's just algebra. I've got to rearrange it and solve for the angle. So we can get rid of this 19 on the bottom by bringing it up. So I can say sine of theta equals 19 sine 60 degrees divided by 17. And then theta is the inverse sine of all of that. Okay, so we need to do the inverse sine of 19 sine 60 degrees divided by 17. So can someone do that on their calculator? So we go to 3 significant figures, so 75.4. Yeah, so that's 75.4 degrees. Okay? Now, when you're trying to find an angle with the sine rule, we can just go through it like this. Okay? So let's just do another example. Again, my diagrams are not to scale, so it might look odd. So we've got 22 centimeters there, 19 centimeters there, and an angle between them of 60 degrees. No, sorry, 48 degrees. Read the wrong question. 48 degrees. And we want to find this length there. Okay? So remember the tip, decide whether it's cosine rule. If it is, use it. If it's not, we use the sine rule. So to find a side, using the cosine rule, we need to know two sides and the angle between them. Is that what we got here? Yeah, so we've got two sides and the angle between them, so we're going to use the cosine rule. So we always start with what we want. So we want x, but remember in the cosine rule, everything's squared. So we're going to write x squared equals, and then it's the other two sides squared, so it'll be 19 squared plus 22 squared minus 2 times the two sides we know times the cosine of the angle opposite the side we want to find, which is 48 degrees. Okay. And then because I'm quite lazy, I don't want to work that out and then do it. I'm just going to say x is the square root of all of that. And remember to put it in brackets on your calculator. So on your calculator, we can go bring up the square root, open brackets, 19 squared plus 22 squared minus 2 times 19 times 22 times cosine 48, and then close brackets if you've got a new calculator. And what do we get? 16.9, yeah. To 3 significant figures. So 16.9 centimetres. Okay? So, sine rule and cosine rule, we've just got to be comfortable using them. Okay?
I wonder if he's a tan rule.
Not that I've heard of.
No, not tan rule. Because that would be
Okay.
cosine sine.
Okay, so we're just going to do one more example. Just before we do a real, well, we can do some forces now. Let's have a look. We'll do this one more example and then take a break, I think. Have a Kit Kat. They probably didn't have that advert here, did they? Oh, they did. Good. At least it's one that works. One of my jokes, usually they don't work because of they don't have it in New Zealand. Like, no, well, not even lost in translation. One of my favourite jokes at school, why don't polar bears eat penguins? Because they can't get the wrappers off. Sam knows the answer, but everyone here go, it's because they don't sell penguins here. They're like Tim Tams, but they're individually wrapped. So it just loses the fact that the things are not for sale here. Right, so let's have a look at a force diagram and then see if we can come up with the resultant force and the angle that it's acting at. So I've got a diagram here. I've got a 20 Newton force acting at 70 degrees there, and a 26 Newton force acting at 40 degrees above the horizontal there. And so we want to work out the resultant force and the direction in which it's acting. Okay? So we could do it by resolving vertically and horizontally, but let's do it by a triangle of forces. Okay, so what is our triangle of forces going to look like? Doesn't matter which one you start with, yeah, but let's start with the 26 one. So there's my 26, and then we put the 20 on like that, and there's our resultant. Okay? Now, do we know any angles in that triangle? We think about here, this one here is 40, and then we've got another, this one's 40, and then the next one's another 70. Yep. So this one in there is 110 degrees. Yeah? Okay, so that's 110 degrees. Okay, so what are we going to do to work out the resultant? Sine rule or cosine rule? Cosine rule, great. Yep. So, of course, we do know two sides and the angle between them. So we can use the cosine rule. R squared equals, so that's the one we're trying to find. So the cosine rule, we need the square of the other two added together. So it'll be 20 squared plus 26 squared minus 2 times 20 times 26 times the cosine of the angle opposite the side we're trying to find, so 110 degrees. Okay. So if you do that on the calculator, then square root it, what answer do we get? So R equals sorry? Sounds good to me. 37.84 here, something like that. Okay. 37.84 newtons. So there's our resultant force. So we know what the resultant is, but we want to say in which direction it's acting. Okay? So I want to know what direction it's acting. So what do we know? We know that that's 40 degrees, and that direction up there would be vertical, so that would be 90. Yeah? So let's work out this angle in here. So we can use the sine rule now to calculate that angle, or the cosine rule. Sine rule is easier though. So we're going to try and find that angle, so we're going to use the sine rule. We can say the one we're trying to find, so sine of theta divided by the side opposite, so the side opposite is the 20, equals the one we know, which is 110, so sine 110 degrees, divided by the side opposite, which is the R we've just worked out, 37.84. So we can just rearrange. Sine theta equals 20 sine 110 degrees divided by 37.84. So theta is the inverse sine of all of that. Okay, so we do that on our calculator. Well, let's just see what I get as well. I think you're right. Sine to the minus 1 of 20 times sine 110 divided by 37.84. 29.8, yeah? Yeah, 29.8 degrees. Now, is that my answer for the direction of the resultant force? No, it's not. So normally we define the direction as a certain angle to the right or to the left, or vertical, or above or below horizontal. So if I know that this angle in here, we've just worked it out to be 29.8 degrees, what's this angle here? That angle there is going to be 90 minus this minus the 40, yeah? So that angle in there is going to be 90 degrees minus 40 minus the 29.8. What did you say that was? 20.2 degrees. Okay, so we can now say, we can finish it off, we can say the resultant force is, so what did we work it out? 37.84 newtons and it's acting 29.8, sorry, not 20.2 degrees to the left of vertical. Good point, thank you. Acting 20.2 degrees to the left of vertical. Okay, so we can define its direction there.